Good morning, everyone. I will see you in about an hour and a half, but thought I would come in early today and make a little video on one of the most difficult lessons that we have done all year, the tangent ratio, getting started on trigonometry. Okay, so I'm trying to make this maybe like 20, 30 minutes at most. We'll see if that actually happens. It'll be a lot more brief than the lesson we did in class on this stuff, but it will still give you some assistance. Now, for the warm-up, this is another one that I don't want to spend too much time doing on video because it was more exploratory in class. But you know that I like things as fractions or as radicals, not as decimals. Where is my eraser? Okay, I like things as fractions or decimals or radicals, but not decimals. You know that I rarely, very rarely want things in decimal form. This is one of those rare times. This is one of those rare times where I want us to practice getting something like this into a decimal form, okay? So I'm going to go over the buttons in the calculator one more time. We're just gonna do 1 and 2, then I'm skipping ahead. Okay, the code to put in the calculator for these, all right, there's 2 options. I call one the safe option and one the risky option. The risky option is obviously faster, the safe option is obviously safer, okay? So for the safe option, it's better to just do the square root of 3 entirely independently on its own, and then divide the answer you get by 3. There's another way we can do it where we put it all into the calculator at once, but that's risky. You can make a little mistake somewhere in there, all right? Another thing, okay, if you have a calculator at home, let's make sure that it is on degrees and that it is on classic, not math print. Click the mode button, Okay, inside the mode, you will see some choices. Deg, rad, because math is rad. No, it actually means radians. Okay, and grad, like you will be one day. A graduate, get it? Okay, whatever. Too early for my jokes. So we're gonna make sure it's in degree mode, okay? Make sure that degree mode is highlighted. Make sure that's selected. Also, make sure that classic down below, you'll see classic and math print. Math print is my arch nemesis. I hate it, okay? I prefer classic mode, and you should too, okay? So make sure you're in degrees and classic mode. And then let's do the code. Okay, the code to do the square root of 3, is to press second. Okay, first you're going to press second. Then you're going to press the x squared button. Again, this is on the TI-30XS, I sound like I'm doing an advertisement, multi-view, Texas Instruments calculator. No, it's on the yellow calculators we got in class. Okay, that's what these button codes are. Yours may be different. I can't guarantee all calculators will have the same button combo. Okay, you're gonna do second, x squared, and that will give you something that looks like this. Okay, it'll look like this. Inside that parentheses, you're going to type your 3. You're going to close the parentheses. Your calculator will still give you an answer if you don't close it. That's a really bad habit. It's a really bad habit to get into. Always close your parentheses. Get in that habit. Okay, press enter. Okay, press enter at this point. You will be given a decimal. Okay, you'll be given a decimal. That decimal is the square root of 3. Now we're going to take, while that decimal is on your screen, you're going to press divide. Okay, that will start dividing this decimal by something. We're going to divide that by 3. Okay, if you did it all properly, let's see, I need to do it myself. Second square root of 3, close parentheses. Notice I get 1.73205, yada, 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 yada. Okay, you're going to divide that number. It'll actually say ans, meaning answer. That means this decimal for the square root of 3 divided by 3. Okay, that will give us our final answer, what we're looking for, which is 0.5774. Remember, I want 4 decimal places for this specific unit. Okay, over here, we're going to do the same general gist. Hold up, wait a minute. Let's go back a minute. Since you can pause the video, I'm going to erase this stuff. You don't need it to be left up. Okay, I'm going to show you the other method. This is more dangerous, but it absolutely works. This is only more dangerous because you could make little mistakes. I want you to start by doing a left parentheses. Do a left parentheses, okay? Inside that left parentheses, you're going to type second, x squared, which will give you this inside the parentheses. Okay, so realistically, what you're going to be seeing at this point is this. Okay, that's what you should be seeing on your calculator. Inside that second parentheses, put your 3, close it, close it, divide by 3, and close it again. Okay, this will skip those middle steps. This will pop you out with 0.577, whatever we had. I don't care. Man, it's already hot in here. It's like, what, 6:30 in the morning? Okay, over here. Same idea, except this one's pretty foolproof, so to speak, to do in one step. Okay, this one you can do in one step by pressing 2. Okay, touch is times, so this is being multiplied. You're going to do times. 2 times. I'm giving you a suggestion. It would still work if you don't do this. It would still work. I suggest after the times, make another open parentheses, then do your second x squared, okay, which gives you this thing, okay? Do a parentheses and then do your square root symbol. Inside that, we'll put the 3 and then double close the parentheses. Make sure there's always a matching right side parentheses to any left side parentheses. These close each other, these close each other. Okay, let's see what that gives us. I'm gonna type it exactly like that in the calculator. 2 times parentheses, second, x squared, 3, double close. That gives me 3.4641. All right, groovy, let's move on. So let's look at some of these triangles here, okay? What do you notice is changing about these triangles? I like to describe it in terms of the amount of energy it would take to climb each of these triangles, okay? Would it take more energy to climb this triangle or this triangle? It would take a lot more energy to climb this because it's much more steep. It's much more vertical. This angle is bigger. This angle is bigger. This angle, okay, is bigger, and the bigger it gets, the more vertical the hypotenuse is going to be, okay? This one is much more flat, okay? It's not steep. It's 30 degrees, and it's much less steep. More importantly, I want you to notice the legs. Okay, remember in a triangle, you have 2 legs, okay, and a hypotenuse. You have 2 legs and a hypotenuse. Let's call this leg A, and let's call this leg B, okay? Let's do the same for each of them. Each of them are A and B, A and B. What do you notice is happening to leg A as the angle increases? Yeah, it's getting smaller. Leg A is getting smaller as the angle increases. What's happening to leg B as the angle increases? Oh, it's getting bigger. Okay, let's pretend that we keep the hypotenuse the same way, and on one of these triangles, let's say this one, I'm going to make the hypotenuse the same way, but it's going to have a much more flat angle, okay? Notice how it goes further out, and if I close the triangle, okay, of course this wasn't perfect, but I'm losing or I'm gaining distance. I'm gaining distance on side A, okay, and I'm losing distance on side B. If I go up to a higher steepness, okay, it's going to be the same idea except inverse. I'm losing A distance and I'm gaining B distance. Notice that's following a ratio, okay? That is a ratio. That is called, well, let's see if you can get there. That is called our, here's the angle, opposite over adjacent. This ratio is the opposite ratio to the adjacent. Opposite of the angle, adjacent to the angle. Opposite to the angle, over, nope, adjacent to the angle. Now, if you were actually in class, I'd point you to that board over there where you see good old SOHCAHTOA. SOHCAHTOA. TOA. TOA. Tangent. Tan equals the opposite over the adjacent. This is a very cool ratio that will always apply to these right triangles, okay? We've already kind of done this stuff. I'm going to keep moving. And as we did in class, I'm going to use the Americans with Disabilities Act, okay, and their regulations for wheelchair ramps as the basis for explaining this ratio. Okay, so the Americans with Disabilities Act says that a wheelchair ramp has a required ratio of rise to run of 1/12, meaning for every 1 unit that the wheelchair ramp rises, let's say for every 1 foot that it rises, it must go horizontally 12 units, or in this case 12 feet. For every 1 feet it goes up, it must extend left or right by 12 feet. So what would you need as the left and right length for a 2-foot rise? Yeah, if it's a 2-foot rise, it's going to be twice as much of a run. It'll be a run of 24, okay? That's the general gist of this ratio. Now, something I want us to just do real quick to keep in mind, because it's kind of cool, all right? Erase that. Let's do 1 divided by 12 in a calculator and get a decimal, all right? Let's do 1 divided by 12 in a calculator and let's get us a decimal. And as far as your homework goes, I'm going to point something out real quick that I pointed out 1,000 times in class. 0, 8, 3 repeated, okay? This is called a ratio, okay? In terms of tangent, okay? In terms of tangent, which I'll get to, this is a ratio. In terms of tangent, this is a value. This decimal is the value. This fraction is the ratio. The fraction is a ratio. The decimal is a value. Those are different things. That does matter. One of your homework assignments, one page is entirely about finding ratios, one is entirely about finding values, okay? So let's look over here real quick, all right? If this is the angle, where the wheelchair ramp rises, where it has its incline, okay, if this is the angle, what side would be opposite of this? The rise. The rise is the opposite. What side is adjacent? The run is adjacent. Now remember, up here, we had rise over run. Is that not the same thing as opposite over adjacent? Are those not the same thing, okay, when the reference angle is that angle of inclination? Right, because that is the tangent ratio. That is the tan ratio that will apply to all right triangles, okay? The rise, or the leg here, the opposite side, divided by the run, okay, this side right here, equals the tangent of that angle. The tangent of that angle, let's say I called it x, equals the rise, which if this is the bare minimum requirement, it would be 1 and 12. Okay, that's the bare minimum requirement. Tangent of x would have to equal 1 over 12. Okay, I'm kind of jumping around here versus what I did in person, but we're going to skip to a little interesting point. Did you know? You do, because I told you in class. Did you know that when you have this ratio, x is something you can solve for? Absolutely. Okay, if you got x all on its lone sum, if you got x alone on one side of this equation, you would have solved for what this x is, what this angle is. We can find this angle by solving for x. Okay, and there is a way to do that. I call it the Freaky Friday. Okay, if you don't understand that reference, go get your parents right now. Bring them in to watch the video. Ask them if they understand what I'm saying when I call this the Freaky Friday method with Lindsay Lohan and Jamie Lee Curtis. Okay? You're going to take the x that is inside the constraints of the tangent. It has no realistic escape. Okay? And you are going to body swap. You are going to swap places. You're going to Freaky Friday with whatever is over here, the ratio that's on the other side of the tangent. Okay? We're going to Freaky Friday body swap right now. Let's rewrite that. I'm going to try and make sure I'm in camera, so I'm going to do it right down here. Okay, the tangent of Freaky Friday body swap, the tangent of 1 over 12, okay, equals x. I just Freaky Friday body swapped that. Lindsay Lohan, Jamie Lee Curtis, okay, they're all swapped up. The only thing that I have to do in order to be allowed to do that is to now change my function, change this tangent, change what I'm doing over here to the inverse tangent. That is a button on your calculator. That button is second and then tangent. Okay, that will give you the inverse tangent option. Now let's get funky with it. Let's do something cool. Let's make this exciting. Let's, in our calculator, do the inverse tangent. Okay, the inverse tangent, second tan, of 1 over 12. Let's do the inverse tangent of 1 over 12. That gives us x, okay? The inverse tangent of 1 divided by 12, this gives us x. X is supposedly, according to our math, x is supposedly 4.7636 degrees. Okay, that is approximately our angle measure of x. Do you want to have some real fun with this? Let's go back to looking at what we have here. Okay, let's look back at what we have here. Okay, let's start rewriting this a little bit. Let's rewrite this just a little bit. Let's rewrite it as the tangent of, well, we know x now, so let's not write x. Let's write what x is. We know it. X is 4.7636. Okay, the tangent of 4.7636 equals, what was the decimal again for 1 over 12? Okay, we're already in decimal form here. Let's get into decimal form. Let's do 1 divided by 12 and put that decimal over here. Okay, it's 0.0833. Now I want you to do one last thing for me. Let's try and make sure this equation's true. Okay, let's try and make sure that 0.0833 does in fact equal 0.0833. In order for that to be the case, the tangent of 4.7636 must be this number. Okay, if the tangent of this is not this number, then we're doing nonsense. Then we're not doing anything valuable right now. Okay, that's just hootenanny. Okay, so let's do it. Tangent of 4.7636. Wow. 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 We just proved that's true. Okay, the tangent of 4.7636 is this 1 over 12 value. Okay, because it is a tangent ratio. It must be. The degree must be 4.76. The degree must be 4.76 in order for this to be a real ratio. Okay? The ratio between the sides and the angle itself are highly related. Okay? So let's check out a couple things here. I'm going to be done pretty soon. Hopefully before I get too interrupted with students. Okay. So, Troy decides to build 2 ramps, each of them with this idea of a 1 to 12 ratio. Okay, both ramps will have this 1 to 12 ratio. The first ramp extends from the front yard, or from the porch to the front door, or something like that, I don't care. Okay, here's the porch, right? And it extends from the front yard, and it goes an unknown hypotenuse. We do know that it goes 2.5 feet vertically. Okay, the porch must be 2.5 feet above wherever it's coming from in the lawn. Okay, we want to know, eventually, we want to know the length of the surface of the ramp. Okay, we want to know the length of the surface of the ramp. That would be, I mean, I would call it this. I don't really want to do that though, because that's Pythagorean theorem and straightforward. What I care about finding is this, because we can do it with that tangent ratio. Okay, I want to find the run of this ramp. Now, if the ratio must be 1 for every 12, 1 rise for every 12 run, and we have 2.5 as the run, or 2.5 as the rise, we want to find x, the run. Just do the shortcut that I showed you a while back. 1 times x, 1x equals 12 times 2.5. I think that's 30. I'm just going to pretend it's 30. 1x, or just x, equals 30. So this is 30. Then you could absolutely find the surface of the ramp by doing 2.5 squared plus 30 squared equals the square root, well, equals x squared. So do the square root of 2.5 squared plus 30 squared. All right? Let's just keep moving real quick. Let's go to the second ramp. Second ramp is the same idea. Let's do the drawing over here this time, okay? All right, here's the front porch. Don't mock my drawings. Okay, I'm sensitive. Okay, it goes up 18 inches. They're 12 inches per foot. I'm not playing that game right now. I'm just going to, it's 1.5 feet. It's 1.5 feet. Okay, the rise is 1.5 feet. Let's find that run. Let's find that run, okay? 1.5, well, let's set it up again the same way. 1 over 12 equals 1.5 over x. 1 times x is 1x, or just x, equals 12 times 1.5 is 18. Okay, so this ramp is 18 feet as a run. Let's do something kind of cool. Okay, we use this ratio. We use exactly this ratio. Okay, and we remember that this decimal was 0.0833. Now let's go over to both of these triangles we did. Let's start over here. Let's do 2.5 divided by 30. Let's see what we get. 2.5 divided by 30. Oh, wow. Oh, wow. Oh, wow. Let's do 1.5, in case you couldn't see the screen, it was 0.0833. Okay, let's do 1.5 divided by 18. Wow. Wow. 0.0833. Okay, notice these ratios are pretty consistent and standard. Now, I'm not going to take the time on this. Yeah, I'm gonna cut the video to an extra short one right here after I go over the cotangent. Okay, the cotangent, in case you ever need to use that one, it's not that much more tricky, okay? The cotangent is just going to be, whereas the tangent is the opposite over adjacent, the cotangent is just the adjacent over the opposite. You will notice the cotangent does not have a button in the calculator. That's because cotangent is really just 1 over the tangent of whatever. Okay, 1 over the tangent of whatever, right? We're not gonna go into why. That's because 1 over opposite over adjacent. 1 over opposite over adjacent, that is a 3-tiered fraction. I don't like 3-tiered fractions. I spelled that wrong, I don't care. I don't like 3-tiered fractions. I do what I gotta do, and it becomes, I'm not going into why I did this in class. Okay, it turns into adjacent over opposite, which is exactly what I wrote here. Okay, that's why the cotangent is just 1 over the tangent. All right, so let's do one more little one right here. This is the last thing I'm gonna do today. So in this triangle, if we want to know the tangent and cotangent values of the 30-degree angle, I mean, we could also do this 60-degree angle here, absolutely. Let's start with the tangent value of 30. The tangent of 30 equals, the tangent of 30 equals the opposite of 30, which is 24. I'm gonna sneeze. Over the adjacent, which is 24 square root of 3. I'm gonna sneeze. Okay. Notice that the 24 and the 24, they can divide into each other and become 1, meaning the tangent of 30 equals 1 over the square root of 3. Okay? I want us to do something fun again. Do 1 divided by the square root of 3. 1 divided by parentheses, second, x squared, 3, double parentheses. Okay, this gives us this value right here equals 0.5774. Now let's do tangent of 30. Tangent of 30. Wow, that's also 0.5774. We're noticing something. Let's do the inverse tangent, okay? Let's do the adjacent, not the inverse tangent, I'm sorry, the cotangent. Let's do the adjacent over the opposite. Okay, the cotangent of 30 is the adjacent, which is 24. Nope, I'm sorry, 24 square root of 3 over 24. Same concept, where these cancel into 1, making the cotangent of 30 equal the square root of 3. Okay, last thing here, we're not going to do the 60-degree angle, but I want to show you. If I do second square root of 3, okay, the square root of 3 is 1.7321. Now, we don't have a button to do the cotangent of 30. We don't have a button for this. What we can do is do 1 divided by, parentheses, the tangent of 30. Because remember, the cotangent is 1 over the tangent. So 1 over the tangent. Oh my goodness, go crazy, wow, oh my goodness, wow. We just proved it again. Okay, the cotangent is 1.7321. All right, I gotta get ready for actual school to start. Good work. hopefully that helps. I'll make another video after school on the sine ratio. See you later.